Hi everybody, this is Miss Bryant and I'm going to show you guys how to perform a type of transformation called a translation. Okay, so I'm going to show you how to do a translation on graph paper and isometric paper. Okay, so we're going to look at a couple examples. And hopefully by the end of this video, you have a better understanding on how to do a translation on graph paper and isometric paper. So looking at this first example, most translations are either going to tell you how to move or tell you where to move. So for example, let's say we're given this question and we're told that A prime is here. We want to move A to A prime. So we're not just moving point A, we're moving the whole triangle to where A prime is, and we need to make sure that it lines up. Now, the only way for us to be able to move this whole triangle to where A prime is we have to figure out how many times up, down, left, or right did A move in order to get to where A prime is. Once we figure that out, we can use that information to move the other 2 points. So, starting from A, I need to figure out how many times I had to go down because A prime looked like it's slightly downward. So I need to figure out how many times I had to move downward in order to get to A prime. So A prime is here. So I'm going to just move my pencil over to where A is, which is right here. So that's 1, 2, 3, 4. So A had to move down 4 times to get to where A prime is. Now I need to figure out how many places it moved to the right in order to get to my destination, which is right here. That's where A prime is. So I'm going to count how many times I need to move to the right to make that happen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it moved a total of 13 times. So it moved down 4 and to the right 13 times. Now that I know how A moved to A prime, I need to do the same thing with points B and C. I need to move B and C the same amount of time to recreate my figure to create the translation. So starting with B, I have to move downward 3 times. Not 3 times, I'm sorry, 4. 1, 2, 3, 4. And to the right 13. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I went over 1. That's a common mistake. So just to double check, make sure I only have 13 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here is where B prime is. Notice I'm using the prime symbol here for my new figure. You use the prime symbol on the image of the original to indicate that a transformation has taken place on the original figure. And the word image basically means the figure that you get after you perform a transformation. So now I'm going to do the same thing for point C. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. C prime. So there is my transformation. I translated triangle ABC, 4 units down, 13 units to the right, to create my new triangle, triangle ABC prime. Let's look at another example on graph paper. Here we have happy square. I'm hoping it's a happy square. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, we have happy square. And so now we have been asked to move happy square up 2 and to the right 4. So I'm going to move happy square up 2 and to the right 4. Now, I wrote this on my paper in the way, so let me erase and write it where it can be seen. Up 2 to the right 4. That's how I'm moving happy triangle. I called it a triangle, didn't I? It's happy square. It's been a long day, you can tell. So starting from point B, I'm going to go up 2 and to the right 4. 1, 2, 1, 2, 3, 4. B prime. You don't always have to do all those marks I did in the first question. I just did that to make sure that you saw what I was describing to you, what I was saying. Same thing for C, up 2 over 4. 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Up 2, 1, 2, 1, 2, 3, 4. All right. So that is my translation of happy square. So as you can see, translating on graph paper may seem pretty easy, and for the most part, I believe that it is. It just takes practice, and that's one thing about math. It's going to take practice. Now I'm going to show you how to do translations on isometric paper. As you can see, the isometric paper is quite different. We don't have squares, we have triangles and equilateral triangles at that. And so with that being said, we have to remember and understand some of our basics about equilateral triangles, because we're going to be using that a lot, especially when we're doing a lot of rotations on isometric paper. But we're not going to focus on rotations right now. We're going to do translations. So how you do translations on isometric paper is going to be slightly different, seeing how I have triangles, they're at angles. And on the graph paper, I have squares and they're straight up in horizontal vertical lines, straight up and down. With the graph paper, you would count the corners. Here it's just a tad different. And I'm going to show you what I mean by that. So here we have for our first example in isometric paper, I have point A and I have to move it to point A prime. So I need to figure out how it did that. All right, so here's where the difference come into play. Normally we would count the corners like that, but that's not going to help us get to A. What you would do is you would count straight ahead to where A is, or A prime is, excuse me. You would count straight ahead. And that takes me 1, 2, 3 corners right here. So using that same concept and idea, I'm going to do the same thing with my other points. So that's 1 diagonal of a square, 2, and 3. If you were to look at these, they do form, these equilateral triangles do form some type of slanted square here. It's still a square, but it's a little bit slanted. So that's what I was saying earlier. 1 diagonal of the square, 2 diagonal of the square, 3 diagonals of the square. So that's what I'm going to do with all the rest of them. B is 1 diagonal, 2 a diagonal, and now 3. And that's B prime. D, I'm going to do the same thing. C, I'm going to do the same thing. C, 1 diagonal, 2 diagonal, 3 diagonal. C prime. And now D. 1 diagonal, 2 diagonal, 3 diagonal. D prime. And so here is my translated shape. And the cool thing that you'll probably notice is that I just made a three-dimensional shape. I just made a rectangular prism trying to translate my rectangle ABCD to rectangle ABCD prime. So it's kind of cool. Isometric paper is kind of neat. All right. And for our last example for translations, if you're asked to move it certain units in certain directions, you would use that same concept of rectangular diagonals and to help you to translate or move the figure to its new location. So this is telling me I need to move 4 units to the right and 4 units down. So to do this unit-wise, moving from here to here is considered 1 unit. And then here to here is 2 units. So this is 1 unit, 2 units. And then this would be 3, and that's 4. All right. So that's how a unit would look if you're asked to move a unit on isometric paper. From here to here is 1 unit, from here to here is 2, from here to here is 3, and from here to here is 4. Now I need to move down 4 units. 1, 2, 3, 4. So my A prime will be right here. All right, I'm going to do the exact same thing with my B. So 1, 2, 3, 4. 1, 2, 3, 4. B prime. And then C. 1, 2, 3, 4. 1, 2, 3, 4. And there is my translated shape. So I just gone over with you guys how to translate shapes on graph paper and isometric paper. I really hope that this video helped you to understand how to do those translations. Again, translation is one of the types of transformations. So again, hopefully this video helped you. If not, feel free to leave me a message if you have any further questions, or you can contact your math teacher and see if they can help you out as well. Have a great day. Bye.